In this lesson, we are going to learn how to distinguish between the three types of stereoisomers. So we have an example here, and our question is, what is the relationship between these two compounds? Are they enantiomers, mesocompounds, diastereomers, or are they identical molecules? It's important to note that identical molecules are not stereoisomers. So before we begin, we just want to make sure that our compounds have atoms that are in the correct spatial arrangement. So if we look at this isomer on the left, we can see that we have an ethyl group, which is our CH3 and a CH2 here, that are both along the side like we have in our 3D model. Next, we have a carbon that has a fluorine going forward, which is depicted by the blue sphere in our 3D model. We have a chlorine that is going back, and you see we have the green sphere for the chlorine that is going back. Next, we have a methyl group that's going up, and you see in our 3D model we have a methyl group that is going up. So try to look at isomer 2 to see if all of the atoms are in the correct spatial arrangement. So now that we've ensured that our atoms are in the correct spatial arrangement, we are ready to determine what types of stereoisomers we have. So the first criteria is to determine if these atoms form a mirror image. So to do that, we're going to choose one of the isomers and we're going to turn it around so that the isomers face each other. So I'm going to choose isomer number 2. I'm just going to turn it around. And so now that they're facing each other, I can see that the green spheres, which are the chlorine, they're facing and they're going in the same direction. These have to look like just like you would look in a mirror. So as long as the colors face each other, like you have the green spheres that are facing and you have the blue spheres that are facing, the methyl groups are both going up and they're facing, and the ethyl group is going back in isomer 1, same as isomer 2. So these two compounds form a mirror image, which means that they cannot be diastereomers. Now we're going to look at our compounds to determine if they have at least one chiral carbon. If they have at least one chiral carbon, these compounds could be enantiomers, mesocompounds, or diastereomers, but they cannot be identical molecules because identical molecules have what we call achiral carbons. So to determine if this compound has a chiral carbon, we're going to pick one carbon that looks like it could have 4 different groups. So on isomer 1, I'm highlighting this carbon, which looks like it may have 4 different groups. So if I believe that my carbon is chiral, I'm going to label it with an asterisk as best I can. And then I'm just going to look and see if this carbon has 4 different groups. So I see that I have an ethyl group here, which has 2 carbon in it. And I see that I have a methyl group, which is 1 carbon, so that's a different group. I also see that I have my fluorine, which is different from the other 2. And I have my chlorine. Since this carbon has 4 different groups, then we know that it is chiral. Therefore, it cannot be an identical, therefore these cannot be identical molecules. We've already established that they form a mirror image, so we know that these are also not diastereomers. So that leaves us with 2 options. Are they enantiomers or mesocompounds? Now we're going to look at these compounds to determine if they have a plane of symmetry. If the compound is symmetric, then it cannot be an enantiomer or a diastereomer, but it can be a meso compound or an identical molecule. Since we've already determined that these isomers are not diastereomers or identical molecules, we are left with enantiomers or meso compound. So if this compound is symmetric, then it's going to be meso. But if it's not symmetric, it's going to be an enantiomer. Therefore, this step here will answer our question. So to determine if the compound is symmetric, I am just going to draw a line right down the middle. And I could really draw this line anywhere. It's going to be a vertical line. And I just want to look at the left side and the right side. And if the sides look different, then it is not symmetric. Keep in mind that you can draw your line horizontally as well, and you can look at the top and bottom. If they do not look the same, again, your compound is not symmetric. Lastly, you can really draw your line anywhere you want to draw it and look at the left and right side. If the sides don't look the same, your compound is not symmetric. So since this isomer is not symmetric, we know that these two are enantiomers. Now that we know that we have enantiomers, we want to do the final check, which is to see if the two isomers are superimposable. So we have our first isomer here, and we've used a different color for each group. So we have the methyl group going up, the chlorine going forward, the fluorine going back, and the ethyl group going towards the side. We've done the same thing with isomer 2. So we first want to check to see if they form a mirror image, which is what enantiomers do. And we see that they do form a mirror image. Now we just want to check to see if they are superimposable. So we're going to turn isomer 2, and we're just going to superimpose to see if the colors line up. We see that the purples line up, but the blue and green do not. Let's turn it again, and we see that the purples do not line up, but the blue does. Because all of the colors don't line up, these isomers are not superimposable. So let's use this table to summarize our lesson. When determining the types of stereoisomers you have to use these 4 criteria. If your isomers have a mirror image, they can be enantiomers, meso compounds, or identical molecules, but they cannot be diastereomers. If your isomers have at least 1 chiral carbon, they can be enantiomers, meso compounds, diastereomers, but they cannot be identical molecules. If the isomers are symmetric, they can be meso compounds or identical molecules, but they cannot be enantiomers or diastereomers. If your isomer is superimposable on its mirror image, it can be a meso compound or an identical molecule, but it cannot be an enantiomer. Remember that diastereomers do not apply here because they do not form mirror images.